Hi everybody, on this installment of Properties of Minerals, we're going to look at the crystal structure. Remember that in order for something to be a mineral, it needs to be a naturally occurring, inorganic solid with a crystalline structure and a definitive composition. So the crystalline structure, the crystals of each mineral grow atom by atom to form the mineral's crystal structure. Geologists will classify these structures into 6 groups based on the number and angle of the crystal faces. So we have our 6 crystal structures right here. Some of them are going to be kind of easy to look at. Things like this piece of halite is a very good example of a cubic crystalline structure. You have the 6 sides. They are at right angles to each other. So this is a perfect example of the 6-sided. The quartz is a good example of a hexagonal. We have 2 sides, and we rotate it in 2 sides, and we rotate it in 2 sides. So we have 6 sides. All right? Now, crystal structure is different than cleavage. We said quartz does not have cleavage, it has fracture. We talked about that, or will talk about it, in the other video. But this is still the way that the mineral grows, and we can see all of these have this hexagonal structure. Now, sometimes minerals grow in a location where that hexagonal structure can't happen, and that's when we get pieces like the one rose quartz, or pieces like this milky quartz. There's still microscopically a hexagonal structure in here. You just can't see it. And this is one of the problems where crystal structure is going to be a little bit tougher to do. All right? And we understand that. We don't need you to learn orthorhombic and monoclinic and triclinic. What we want you to know is cubic. Okay? Cubic is easy. Cubic is a cube. It's right angles. You should know cubic. You should be able to look and come up with hexagonal structure. And I'll put my fingers around this so you can see that's easy, those 6 sides for that hexagonal structure. All right? So this piece of corundum, 6 sides, that's going to be hexagonal. Instead of triclinic, you can look at this piece of optical calcite, this Iceland spar, and you can see that it has a rhombohedral shape. It kind of looks like a square that's been pushed over. So while we still have the 6 sides, they are not at right angles to each other. So this is going to be a rhombohedral shape. All right? Sometimes it can be really tough to determine crystalline structure. If we look at this azurite, which is the blue, it has a crystalline structure, but you're not going to be able to tell on this particular one. Sometimes, like this piece of pyrite, pyrite actually has a cubic crystalline structure. And you would have to really kind of get in here. I don't know if I can even get close enough on this to be able to see that cubic crystalline structure. But sometimes minerals grow in a tight, confined space, and we get something like this. This is known as a pyrite sun. This is pyrite. The cubic structure is in there, but you would need a magnifying glass in order to look at it, or a microscope in order to look at it. So what we see is this. It actually, inside, microscopically, is this. All right? That's crystalline structure. Again, for you guys, for this age, you're going to look at it. You're going to see things that are a cubic shape or a rhombohedral shape, and that's how you're going to look at it. All right? Thanks, everybody. See you on the next video.